Hello everyone, I am Shumona. Today I am going to discuss about our team project, that is the retail sales predictions on linear regression. So meet my team member. Is the first Rishi, myself Shumona, Jitendra, Ankit and the Mayank. Here is the project summary. So from the project summary we can get a gist of our project. So this is the dataset, is a live dataset of the Rossman store, and on analyzing this problem we observe that the Rossman problem is a regression problem, and our primary goal is to predict the sales figure of Rossman problem. Analyzing the data set by using the EDA, using exponential moving average analysis, trends and seasonality in Rossman dataset, analyze regression analysis using following prediction analysis, that is the linear regression analysis, elastic regression, that is the Lashman Ridge regression, random forest regression, and AdaBoost and XGBoost. By applying the above algorithm, we find accuracy of 98% by XGBoost. And here is my GitHub link. You can get the idea of the project from visiting by GitHub link. And is the problem statement. Rossman operates over 3,000 drug stores in 7 European countries. Currently, Rossman store managers are tasked with predicting their daily sales for up to 6 weeks in advance. Store sales are influenced by many factors, including the promotion, competition, school and state holidays, seasonality and locality. So the task is to forecast the sales column for the TC. And for that, we first describe our data, and in this data, the two type of data set also having. One is the Rossman stored data.csv, and it says about the historical data including the sales, and the another is the stored.csv. It tells us supplemental information about the store. Now we know about the descriptions of the variable of the data, that is the ID. ID represent an ID that double within the test set, store and a unique ID of each store, sells the turnover for any given day, customer, the number of customer on a given day, like open, that is 0 means closed, that is the store was closed, and 1 means store was open, like the school holiday, store type, assortment, competition, distance, promo. Promo indicate the promotion, and promo 2 is a continuing and consecutive promotion for some store. 0 equal to store is not participating, and 1 equal to store is participating. And the same way promo 2 since year or week, promo interval, like that. Now let's come to our project part, and for that we have to import some important library like Panda, Matplotlib, Seaborn, AST, Math, Random, and Sklan, and we have to load our data set. And for that we have to mount our Google Drive, and here is the link, direct link of the data, two type of data set, and we have to read first the CSV files. For that we used pd.read CSV, and we read that CSV files. Now we checking the first 5 rows of the sales data frame. For that we use .hit method, and by using this we can get the 5 rows by default. And next we want to know about the information of the sales data frame, and from that we used .info method, and by this we get a clear cut idea about the columns available on the sales data frame and the data type of the columns. Now now we want to we want to know about the last 5 rows of the sales data frame. For that we use .tail. Now we want to know the statistical information like count, mean, standard deviation, minimum, maximum, first quartile, second quartile, third quartile. We use .describe. For checking the unique value of the state holiday column of the sales data frame, we used dot value count, and from that we can get the 0 having that much of A and B, C having that much of values. And to check the unique value of date columns of sales DF, we use dot unique, and from that we get that date column having 2013 to mid of the 2015, that is the 2.5 years data, sales data. Now we check the null values is having or not in the sales data frame, and we use dot is null dot sum, and we see that any of the columns not having any null values. Now we check the store data frame, that is the another data, and by using dot info, and we get that. Now coming to the wrangling part, in the wrangling we check the unique value of the school holiday columns of the sales data frame, and we get that array of 1 and 0 values are there. Now we check the null values is present in the store data frame or not. For that we used store df dot is null dot sum, and we get that competition distance column having 3 null values. Competition open since month, competition open since year also having 354 null values. Promo to since week, promo to since year, and promo interval also having 544 null values. And we have created a list, and in the list we take the day of week, state holiday and school holiday column. For checking the unique values of the 3 columns, we use the loop for loop, and here we get that result, that is a day of week column having 4 5 5 4 3 2 1 7 6 value, state holiday having 0 A B C 0, and school holiday also having 1 and 0. Now we check the unique values of the store data frame, and we get that store column having 1115 unique values, store type also having 4 unique values. Okay, before we check that competition distance, competition open since month, competition open since year, promo to since week, promo to since year, promo interval, that columns are having null value. We fill that null value to the 0 by dot hidden. Now we again check that any missing values is having or not in the stored data frame. For that we used stored data frame dot isna dot sum, and here is the result. So they are in any column not having any missing values. Now we are calling the stored data frame, and here is the finally we match the two data frame on the basis of the common column store, and named is giving named as final one, and we check that final one having about 1,17,219 209 rows and 18 columns, and some of columns having object type of data, categorical value, like A, B, C. You can see state holiday having some object type of data. Why state holiday having object type of data? State holiday in sales. State holiday. State holiday and the assortment and the store type having categorical data. We have to convert them into numerical data for our better understanding in visualization part and for our in training or model part. So we are changing it into the categorical value to the some numerical value like 0 to 0, A to 1, B to 2, C to 3, and we are also changing the um, data type, that is before that it having object type data, we convert it into integer type by using dot f type. Like that assortment also we are changing, and store type column also we are changing. Now we are checking that unique value of these 3 rows. these three columns, and we get that state holiday having 4 unique values, assortment having 3 unique values, that is the 0, 1, 2, and the store type also having 4 unique values, that is 1, 2, 3. Now we are checking that final one info by using dot info, and here you can see that maximum columns are having integer value instead of date having object, and comparison distance, comparison open since month, comparison open since year also having float type of data, and promo to since week, promo to since year having also float type of data. We have to change it, and now where value counts the sales or target variable, and here you can see that zero value is having like 17,000 to 1,72,871 values and like that. Now we are uh, changing the format of the date column of the final one, and by percentage y, percentage m, percentage d, and we are extract the we are changing that data type from object to integer by using date dot date time index. It what it date time index run here, dot date time index extract the number of months is there, uh, and that converted into a numerical value, and that's in this way the competition opens since month data type are converted into object to integer, and again we are converting that competition open since year, promo to since year, and comparison distance promo to since week to integer, and now we are checking that final one data frame, and almost all the columns are having integer value instead of promo interval. Now we are checking the first 5 rows of final one data frame by using dot head, and we have to check the statistical informations of the final one data frame by using dot describe, and we want to uh, get a result about two decimal places. For that we applying the lambda function here, and we can get that point 2 decimal places result. You can see that is the standard deviation having store having 321.91, that is 0.2 decimal places result as showing. Now coming to our most important part, that is the data visualization, and from the visualization we can visualize our data by line chart and menu of the chart, that is the box plot and pie chart like that, and we are creating a line chart first, and between the cells and the competition open since here, and from this plot we can see that in the year of 1900 sales is the most, and and when the year is going on, the sales were up and down, but that much of hike is not happened now, because now day by day the competition is also increasing. Now again we are plotting a point plot between the sales and the promoter since here, and from this we can see that in the 2013 and 2015 promotion is very less, for the sales also dropping. Next, we are creating a point plot between the sales and the day of week. Here is the day of week is 1, 2, 3, 4, 5, 6, 7 represent the Monday to Sunday, and you can see that in the seventh day of the week, that is Sunday, the sales is very low because maximum store was closed in that day. Now we are creating a point plot and try to make the relationship between the sales and the competition open since month. And from this you can see that in the month of the 12th, that is the December, the sales is most. Now when to distribute our variable, that is the sales value. We create a box plot between the store type and the sales. Store type is divided into 4 type of cells stored, that is the 0, 1, 2, 3, and you can see from the box plot that one type of box plot outlier ranges lies between the about 23,000 to crossing it touching the 40,000, and store 0 type outlier is ranging from 15,000 to it crossing the 40,000, and some of outliers there, and the outlier, the gap between the outlier also present in there. Now we are creating a box plot for sales value and the assortment. In the assortment, they are having 3 type of assortment, that is 0, 1, 2, and from the box plot we can see the distributions of the assortment versus sales. Now we are creating a count plot between the count and the day of week, and here the blue one is represented the store was open, and green one is represented that store was not sorry, store was sorry, 0 1 is 0 represent the store was uh, not open, and 1 represent that store was open. And we can see that in the Monday to Saturday the store was open, but in the case of the Sunday the store was closed. Next, we are making a count for between that uh, count day of week versus promotion, and you can see from this graph the Monday to Friday almost the promotion and the sales are almost same, but in case of the Saturday and Sunday the promotion is not going on, and for that sales also decreasing. Now we make a bar plot between the promotion and sales, and you can see when promotion is going on, sales also increasing, and vice versa also. Mm. Now we make a bar plot between the sales and the state holiday. Here the state holiday is the 0, 1, 2, 3. What 0, 1, 2, 3 represent, that is 0 represent the public holiday, 1 is represented by Easter holiday, and 2 represents Christmas, and 3 is the non. And from this graph we can see that 0 type state holiday, that is the public holiday, is the most in the public holiday sale is the most. Now we are making bar plot between the sales versus school holiday, and here the 2 type of school holidays, there 0 and 1, and you can see one type of one means public holiday. In the public holiday the sales is the most compared to the non-public holiday. So we can conclude from our ETA part. Plot sales and competition open since month source. Sales go increasing from November and highest in the month of the December. And from plot sales and day of week, sales highest on Monday and start declining from Tuesday to Saturday, and Sunday sales almost near to zero. Lot between promotion and sales shows that promotion helps in increasing sales, and all type B store never close except for refurbishment or other reason. All type B store have comparatively higher sales, and it mostly constant with peaks appears on weekend. And assortment level B is only offered at store type B. We can observe that most of the stores remain closed during state holiday, but it is interesting to note that the number of stores open during school holidays were more than that were open during the state holiday. Now we are coming to the most important part of our email project, that is the feature engineering and data pre-processing. Feature engineering and data pre-processing is nothing but it is one type of pre-process or data for modeling, and we create a heat map and try to make the correlation between the sales versus other variable, and we observe that open and sales are highly correlated, and that is 0.6, that is 68% correlated with each other. Multicollinearity. But before going to discuss further, we have to know the what is multicollinearity, how it becomes a problem on linear regression model. When two or more than two independent variable are highly correlated with each other in the linear regression that calls the multicollinearity. And when the multicollinearity is become a create a problem, multicollinearity is happen in the linear regression model. That time the coefficient of the coefficient of the each linear regression create a unstable relationship between the dependent variable and the independent variable. So to detecting that multicollinearity, we have to calculate the VI values. What is VI? VI is the variance inclusion factor, and in practically is value mathematically VI equal to 1 by 1 minus r square. But when we did it practically, we have to import variance inclusion factor from stats model dot stats dot outlier influence, and we can check the VI value. Okay, now we check the VI value for cells respecting to other columns, and we check that store having 3.69 day of week having like and almost and open having highest VI values. And actually VI value is starts from 1 and is going on up. It's have no upper limit, but 1 means there is no multicollinearity, and 5 to 10 its VI values range is between 5 to 10, is lies between 5 to 10. That means our model becomes good. And here you can see that promote to column and promote to sincere having almost same VI value 1.574. So we can drop any of them. So we drop that promote to column. Now we are checking the we again check the VI value. Now we create a histogram of cells, and here we see that zero type of data is having like that, zero cells, 0 is there. For that we count that when open is equal to 0 and cells is equal to 0, how much values is there, and we see that about 1,72,817 are there. So we will drop those store which cells is 0, assuming that the store was closed temporarily, and this will help to train the model well accurately. Now we create a new data frame by dropping our pin equal to 0 and cells is equal to 0, and we check the shape of our new data frame, and here is here is one, that is the 8,44,392 rows are there and 18 columns, and we call the new data frame. We can see that. Now in new data frame set, column name promo interval changes into dummies. It means that each new column will have a binary value 0 and 1. So we can check that promo interval having only 1 and 0 value. Now we converting that new data frame to a CSV file named cleandata.csv by using .to.csv, new data frame .to.csv. Now coming to the hypothesis testing. In the hypothesis testing part, we create two type of model. One is the excluding rows which has cells equal to 0, and by taking whole data set. Now it is the time for implementation of our model. For training the model, we have to import some important libraries from the sklearn and the light GVM, CPy, it's like that. And we create the model one excluding rows which are cells equal to 0. For that, the dependent variable is the cells, and independent variables are the exclude of the chromato sincere and dead cells. You can see the independent variables are here. Now we are plotting the independent variable and dependent variable into x and y, and we are splitting the data set, that is x train, x test, y train, y test, and here is the test size equal to 0.2, that stands for the 20% of the data are going for trained data set, and remaining 80% are going for the sorry, 20% of data are going for trained dataset and 80% are going for test dataset. And random state equal to 0, it means there is no change in the, if there is any we are taking any data randomly, there is no change in the result. And we can check the save of the x10 and x-test. We are printing that here is one. Now we are taking linear regression and we feed that into our model, and we check that regression score is 0.76 and regression coefficient is like that, and we check regression intercept is 700.174, and we get the y prediction value like that and y test value like that, and we predict the trend by using the regression, and we calculating the MSE value, that is the mean square error, RMSE value, that is the root mean square error, and R square value. And we get that from linear regression of model 1 is 0.7634, that is the 76.34% we are getting from the linear regression. Now we are keeping that y test and y predict for getting the actual and prediction value in all together, and we get that in the prediction value is lower than the actual value. For that we install further we have to regulate it by using lasso and reach like that. And for understanding our ML model easily, we have to input some ML interpreter like SAP and line, and we install it by pip install SAP, pip install line. Now we read that clean data CSV by using .read, and we extract year, month, day of week from the day column like that, and we create a list named features, and we put that store, day of week, promo, state holiday, school holiday, year, month in that list, and we split the data set into the training and the test set, that is x10 x test and y10 y test. Here also the sales is the independent variable. Sales is the independent variable, and here also test size equal to 0.2. That means 20% of the data will taken for the test, and the remaining 80% is going for training. And random state helps to maintain the same result, that is the training and the testing data for different run. If it would not have been mentioned in the, then the data keeps on changing. So we have not we don't want that. For that we keep that random state equal to 42. Actually some of machines are taking random state equal to 42, it's okay, and some of machine take random state equal to 0 is okay. So when this two also right way to take the result permanent. Now we choose the linear regression, and we feed that linear regression by .fit, and we calculate the SAP value and line value, and we plot that the SAP value impact on model output. Here you can see from this graph. Now we are choosing some regularization for our better R square value. We are choosing a lasso, that is Elon regularization, and we take alpha is equal to 0.4, and we get that cross validation score and cross validation mean cross validation score, and from that we extract that based alpha lasso is equal to 0.2, based score lasso is equal to 0.7605, that is 76.05%. Now we keeping that y test and y predict lasso, and we get that the prediction value is now improving compared to the actual value. So we want to improve our model so far. So for that we used reach regularization. Reach regularization is nothing but L2 regularization, and here we take the alpha is equal to 0.5, and we from this we get L2 score is equal to 0.14, and we get that best alpha value is 0.5, maximum CV score, that is the cross validation score, is 0.77, and we want to uh, we want to apply the elastic net in our model. So we apply the elastic net and we get the alpha values in the range of 0.1 to 0.5, and in L1 ratio is range between 0.1 to 0.9. It is the gap between the two, that is 0.1, 0.3, 0.5. That is, it takes the it takes alpha L1 ratio into gap of 2, and from that we get that the best alpha value is 0.1, best L1 ratio value is 0.9, base score is 0.76316, and test score is 0.7631, and we apply the disease entry for our improvement of our model. So we mean the sales column, and here we get the 5773.81, and we calculate the MSE, RMSE, RMPSE, R square value, and we get that R square value is about 0.79, that is a 79.05%. Now we coming to our model 2 by taking the whole data set. Now final one, we in the final one data set, the column name, the chromo interval changes into the dummies. It means that each new column will have a binary value, that is 0 and 1. Now we check that final one dot head, by default it gives the first 5 rows of final one data. Here the dependent variable are cells and independent variables are dropping the store and promote to sincere and date cells, and remaining other independent variable. We plotting independent and dependent variable into U and V, and we get that U and V value from here. Now we are checking that independent variable of final one data frame, and here is the result. Now we split our data set by U train, U test, V train, V test, and we are also taking the test size equal to 0.2. And here is the shape of U train and U test. Now we take the linear regression and we fit that linear regression by dot U train in V train. Now from that we get the V predict value linear regression score, that is 0.86, that is 86.779, and we zip that V test and V predict value in a single data frame, that is a regression data frame, and here we get that prediction value is decreasing compared to the actual value, so we have to improve it. For that we calculating MSE, RMSE, RMPSE, R square value, and um, from that linear regression we get that R square value is 86.84, and to improve our model, we select the decision tree in our model, and we also calculate the MSE value, RMSE and RMPSE, R square value here, and we get that 86.879, that is almost 86.89% of value we are get. So it is the improvement in the nature, R square value is improvement in nature, and again we are seeing that the prediction value is now decreasing compared to the actual value. For that we use the random forest and we calculate again the MSE, RMSE, RMPSE, R square value, and we get the 92.41% of R square value. And again we are using AdaBoost regression. We get the R square value is 84.44%, that is the decreasing in nature compared to the before we are using random forest, and that's why we are used XGBoost regression, and we get that from that we get the R square value is 0.9879, that is the 98.79%. We think that the R square value is great enough for our model. So we can conclude that we saw that the sales column contains 1,72,817 rows with 0 cells. So we created a new data frame in which we remove zero cells rows and tried to train our model. We used various algorithms and got accuracy score about 74%. And we were also curious about the total data set including cells equal to zero. And so we trained another model using various algorithms and we got accuracy near about 98%, which is far enough for better previous model. And so we came to conclusion that removing cells equal to zero rows actually remove a lot of information from dataset as it has 1,72,817 rows, which is quite large, and therefore we decided not to remove those values. We got our best RMPS score from the random forest model, gradient boosting technique like AdaBoost, XGBoost. So we tried taking an optimum parameter so that our model does not overfit. So that's it. That's all. Thank you all.